everyone, this video is to show you how to do a two-way ANOVA or an ANOVA with two factors. So our data is a little different from the single ANOVA or the single factor ANOVA that we did previously. Now you'll see that instead of just having data for Nebraska, North Dakota, and South Dakota, we have that data based off of 2 years, so 2 separate times. So the type of questions we can answer with a two-way ANOVA is, does the average corn yield differ among the 3 states? And does the average corn yield differ among the states depending on the year? So what we find is we've got 3 null hypotheses. The first one being, do the factors of state and year even interact? So the null hypothesis is that they do not interact, because if they do interact, we can't use a two-way ANOVA. So we hope that we fail to reject the null hypothesis with a two-way ANOVA. We don't want the fact that the years would be interacting with the states. After that, once we find that interaction to not occur, so once we are able to fail to reject our null hypothesis, this green one, we then can look at our other 2 null hypotheses and look at the means of all states being equal and all years being equal. So to run an ANOVA, a two-factor ANOVA, it's fairly simple. We go to our data tab, go to that data analysis tool, and click two-factor with replication. That replication means that we have multiple variables for each factor. So for Nebraska in 2019, we have 1, 2, 3, 4, 5 replications. Same thing for 2018, we have 5 replications. So that's what that with replication means. So we are going to select our data, and our output, we're just going to say, F8, and we're going to say, when it says for rows per sample, that means we've got 1, 2, 3, 4, 5 replications. So 5, and we're going to use the alpha of 95%, so an alpha of 0.05. Click OK. We somehow got to 122. We only want, oops. There we go. We want A2 through D12 for our input range. Now it worked. Okay, so what you're going to see at the top is we've got our averages and our counts based off of year, split up, and then we have a total. Then down here at the bottom, you're going to see that ANOVA, just like we did with the one-step ANOVA. First thing we want to look at is that null hypothesis of the factors interacting. So we come down to this interaction right there. I'll highlight that. So with that interaction, let's find our p-value. And we find that our p-value is 0.77. That's good. That means that there is no interaction. We cannot accept, or we cannot reject our null hypothesis. So we are failing to reject it, that there is any interaction. So we know that there is not interaction between these 2 factors. So that was our first step. Now we've got to use that Tukey-Kramer test again to figure out, okay, we know we know that the factors do not interact. So now we've got to figure out these null hypotheses and see if they actually show means being equal or unequal. So we'll start with our state being our factor A. So we'll type in our Tukey-Kramer, and we have to build a table like we did for the one factor ANOVA. We're going to say factor A, state. So we're going to do that same thing. We're going to have Nebraska, North Dakota, South Dakota, Nebraska, and South Dakota. And then we're again going to have our differences. We're going to have our B, which is the number of levels of year, because that's our factor B. And then we're going to have our R, which is our number of replications, which doesn't change either way. We've got our critical range, our outcome, and the meaning. Make these a little bit bigger here. All right, so to find that critical range, the first thing we need to do is again find our critical Q. This is again from page 852. We need to find our D1 number, which D1 is the number of levels for factor A or for state. D2 is a little more complicated. For D2, we actually have to take the product of the levels of the state and the levels of the year and multiply it by the replications minus 1. So that looks like this: A times B times R minus 1. Actually, I'll move that down one so you can still see it all. All right, so let's make this just a little bit bigger. I'll wrap that text. My D1 is the number of levels for states. So we have 3 states, so D1 is just a 3. Now for D2, we have to take the number of levels, but it's the product of, again, the level of states times the level of year. So 3 times 2 times number of replications 5 minus 1, which is 24. So then if you flip to page 852 in your book, you'll see that if you go D1 across the top is 3, D2 is 24, we find that our critical value is 3.53. All right, so now we've got to find our differences. So this is the same as it was with a 1 factor, except we're looking at differences in 3 different tables. Oops, sorry, not 3 different tables. We're looking at our total right away, okay? So for our differences, we're going to find our absolute value of the average. And this is going to be that first one since it's in this column. This is going to be your North Dakota or your Nebraska because that's what we had first was Nebraska. As you can see, the summary just goes all the way down. So Nebraska minus North Dakota. Close that. And since they go across here, then this is where we're looking at our total amount. Since we're going across, we can't just fill it down, so we have to redo it. So equals, and we want North Dakota, the absolute value, because again, we don't care which one's higher. North Dakota minus South Dakota. Close that. Type it in again. Absolute value, Nebraska minus South Dakota. So those are our differences. The number of levels of year, well, we have 2 years, so that's just going to be 2 all the way down. We have 5 replications, so that's 5 all the way down. So now we've got our critical range, and to find your critical range, we are using the formula on page 543. So our formula is equal to our Q, so that critical Q, times the square root of your mean standard error within, so here's our within mean standard error in that ANOVA, because we're looking at it within, not the interaction, divided by your B times your R, which will be 10 in this case. And since we're going to use the fill down method, we want to absolute reference both D46 and I35. Hit enter, and we fill it down. Obviously, and it's going to be the same because our levels are the same and our replications are the same for each year. So now for my outcome, we need to look and see, is our difference, we'll highlight that in green, greater than our critical range? If it is, we are going to reject our null hypothesis. And if you see, we've got, for Nebraska and North Dakota, we've got higher, our difference is greater. Same with our North Dakota and South Dakota. It's closer, but it's still greater. And our Nebraska and South Dakota is also greater. So we are going to reject all of these. So the meaning behind that is we're coming back up to this second null hypothesis. The means of all states are equal. We are rejecting that, and we are going to conclude that the means are different. So the corn yield is not equal between North Dakota and Nebraska. And then we'll just change the last state, so between North Dakota and South Dakota. And between Nebraska and South Dakota. So with this test, we would find that the means are all different among each state. So that you could claim that the average corn yield in Nebraska is not the same as the average in North Dakota or South Dakota when you compare all of them. So that was the Tukey-Kramer for factor A. So now we need to repeat this whole thing, but using factor B, which is the year. So that way we can answer the rest of the hypothesis. So this blue hypothesis, meaning the means of all years are equal. So we're just going to copy and paste this Tukey-Kramer, and we're going to then tweak it. Oops, let's make sure we get all of that. But instead, here we get to delete some stuff because we only have 2 years to look at. So we're going to delete 2 of those. So 2018 compared to 2019. And our differences, we'll just get rid of that for now. We've got it built. We'll come back to that too. All right, so our critical value. Here are D1, we're looking at Tukey-Kramer for factor B, which is year. So we have 2 factors, 2018, 2019, so those are the only within that we need to look at. So we again need to find that critical value. Well, D1 is now our year, so we only have 2. Our D2 stays the same because of the fact that we would just be flipping the 3 and the 2. So 2 times 3, 2 times 3 times 4 is still 24. So again, go to page 256 or 852, and you find that when we have level D1 as 2, and then 24, it should be 2.92. All right, so let's fill this in. So now when we're looking at differences, we're again still looking at our absolute value, but now we need to find the difference in the averages of 2018, 2019. So that's where we need to come up to these 2 areas. So we need to take our difference of our absolute value, our average of 2019 minus our average of 2018. So here it would be J14 minus J20, and we get our mean of our difference of 9.89. Again, you got that from looking at the summary for 2018, 2019, looking at those average values there. All right, so now B, so the levels of year, it's not going to be the levels of year anymore. It's going to be the level of state this time. I believe that is correct. Yep. So it's not going to be a B. We need to flip that to an A. So the levels of state, which is 3 levels. And then we need to look at the number of, again, the number of replications, which we still have 5 of each one. So to get our critical range, we again type in our Q value. And we don't want that to change, so let's absolute reference that. Ooh, let's get rid of the red before we do this. All right, let's try this again. Equals our Q, absolute referenced, times the square root of our mean within, still that I-35, our mean square, excuse me, we're still getting that mean square error, so the MS between there, so the within. And again, we want to absolute reference that. Well, I guess it doesn't matter, we don't have to fill it down, but if we did, we would absolute reference that. Divided by our level of state times the number of replications. Make sure we close that. So again, we've got our Q value down here times the square root of the mean square error. So up here from the within interaction, or the within source of variance, and then all divided by our level of state times our number of replications, and we get 14.29. So we find that here it's different, and our outcome is that we fail to reject due to the fact that our difference is smaller than our critical range. And when we fail to reject, what that tells us is that the means among the states are not different. The mean corn yield among different states, we'll say among states, is equal between the years of 2018 and 2019. So that's how you run a two-way or two-factor ANOVA test with 3 separate types of hypotheses.